Hi, Calculus 1 students. So in the playlist extra examples for midterm, we want to differentiate this function. We are in the section 3.4 in which we are using the chain rule. Okay. So there's more than one reason I do this example on a video. First one is because the variable is t, so just to get you used to different letters. But also another thing that is important is that this is a here. Okay, in this case, a is a symbolic constant. And let's actually see what happens with that symbolic constant, because we might have to make assumptions on it in order to simplify this as much as we can. But for now, let's just say that a squared is a symbolic constant. Like, there's nothing more to say about it. All right, well, how do we differentiate this? Part of it is the chain rule, part of it is the quotient rule. Okay, so what is performed last is the division. So let's do it. So first thing I'm going to write is just, and I highly encourage you to do it. Just rewrite the problem. Take this opportunity to do the preparation step, right? So this step right here, we call this a preparation step. And we want to take the derivative of this. Okay? So the first thing to do is to use the quotient rule, which means you're going to take the derivative of the top. And I'm not going to go too fast here, like sine of t e to the t, okay, times the bottom, which is like t squared plus a squared to the 1/2, minus, and then the top times the derivative of the bottom, okay. So again, I'm not writing anything more than just t squared plus a squared to the 1/2 prime, okay? And we are dividing, and okay, I'll be really lousy here, but you will see very quickly what happens. So t squared plus a squared to the power of 1/2 squared, okay? Where I'm not, don't confuse the brackets here. I'm not taking another derivative. Maybe it's safe if I use a round bracket here. So quotient rule is out of the way. Now, each of them, we will use the chain rule. And, okay, so the outside function is here. So it's the sine. And the inside function, I like to actually like underline the bracket so that you can see where the outside function ends. And the inside function is this. Now, remember the outside-inside rule. You have 3 steps to follow. First step, you take the derivative of the outside function. So in other words, it's going to be like cosine. Stick the inside function in, t e to the power of t. And then take the derivative of the inside. Now, the derivative of the inside turns out to be a product rule, so be careful about it. I'm not going to color code it, but quite simply, 1 times e to the t plus t times e to the t. Okay, so that's the derivative of the inside. Okay, so just to be crystal clear, like this is what we have here. Now, don't forget, like this is just part of the big problem. T squared plus a squared to the power of 1/2 minus sine of t e to the t. And now we need to differentiate this. Well, it's the exact same idea. The outside function is the to the 1/2. So step number 1, take the derivative of the outside. So like that's it, negative 1/2. Stick the inside in. So in other words, it's going to be t squared plus a squared. And then finally, take the derivative of the inside. Be very careful. It is simply 2t plus 0. Why 0? It's because I remind you that a is a symbolic constant. So since a is, well, since a squared actually is a constant. And now, okay, let's take advantage of what we have here. So let's simplify the 2 and the 1/2 by multiplying these exponents. You will get just 1. So here we are. You'll have here just t squared plus a squared. So I could ask you to simplify that derivative, but honestly, it would be counterproductive. So I think I will just end it I will end it here. So simplifying this derivative is not something I'm likely to ask, because it's really what I want to know is if you're able to differentiate. All right, hopefully this was helpful. See you in the next video.